China has set its sights on becoming a global powerhouse in commercial aviation, aspiring to establish COMAC, Commercial Aircraft Corporation of China, as the C in the new ABC world order, alongside Airbus and Boeing. This ambition is no longer just a vision, it's taking flight. The COMAC C919, a modern narrow-body airliner, designed and assembled in China, stands as a powerful symbol of this progress. Certified, operational with airlines like China Eastern Airlines, and backed by over 1,000 orders, the C919 represents a monumental achievement in China aerospace engineering and industrial capability. Yet, beneath the triumph lay a critical flaw. While the C919 features a Chinese-designed airframe, about 40% of the model's components are imported. The C919 depends entirely on LEAP-1C engines from CFM International, a joint venture between GE Aerospace from the US and Safran Aircraft Engines from France. This strategic dependence leaves the program acutely exposed to geopolitical tensions. In May 2025, President Donald Trump issued a ban prohibiting the export of key US aircraft engine components and technologies to China, directly targeting the LEAP-1C engines powering the C919. This move threatens to disrupt the jet production, as well as the obtaining process of international airworthiness certification. But does this come as a surprise to China? The answer is no. China has anticipated this scenario from the beginning. While developing the C919, it simultaneously pursued development of the CJ-1000A engine. The decision to initially use foreign engines was a strategic choice, one driven by several key considerations. First, there was a matter of international certification. For the C919 to succeed globally, it needed a proven Western engine. This gave it credibility from day one, making airlines far more comfortable placing orders, allowing COMAC to build a customer base and gain operational data while continuing the CJ-1000A development. Another major factor was minimizing risk. The LEAP-1C was already a mature, high-performance engine, with a proven track record on other aircraft, significantly de-risking the C919's initial entry into service. There was also a long-term industrial benefit. Even without formal technology transfer, working closely with companies like CFM provided Chinese engineers invaluable exposure to the best practices in the world. This hands-on experience accelerated their own domestic engine building capabilities. And finally, there was a geopolitical aspect. Choosing a Western engine initially helped avoid provoking the very type of trade restriction that materialized in May 2025. Contrary to common beliefs that China is dependent on foreign technology, importing foreign engines represented a rational choice within a broader commercial and strategic roadmap towards self-sufficiency, not a lack of alternatives. So, how far along has China come? Let's take a look at the progress of the two engines, the CJ-1000A for the C919 and the CJ-2000 for its larger sibling, the C929. The CJ-1000A is China's first domestically developed large high-bypass turbofan jet engine, capable of generating from 98 to 196 kN of thrust, around 10 to 20 metric tons, placing it in the same class as LEAP-1C, with the 125 kN of thrust, approximately 12.75 metric tons. The CJ-1000A has a payback ratio of 10:1, compared to the LEAP-1C 11:1. While a higher bypass ratio typically improves fuel efficiency, the CJ-1000A fuel consumption remained approximately 8 to 10% higher than the LEAP-1C due to its earlier development stage. However, it achieved lower noise level through advanced acoustic liners and optimized fan design. Key parameters like thrust-to-weight ratio and noise control approach international standard, with notable progress in single crystal turbine blades and FADEC full authority digital engine control systems, technology that were once strictly embargoed by the West. The CJ-1000A engine has successfully completed over 2 years of flight testing on the Y-20 heavy transport aircraft, accumulating more than 4,000 flight hours. In March 2025, at the Taycan Aero Engine Technology Conference, Aero Engine Corporation of China, or AECC leadership, confirmed that CJ-1000A performance exceeded expectations and was about to undergo flight verification on the C919. According to domestic media reports, the CJ-1000A has passed the Civil Aviation Administration of China's certification, or the CAAC certification, production license, and individual aircraft airworthiness testing. It is now in the final stage of the airworthiness certification. Some core components have reportedly operated without failure for over 1,000 hours. AECC expects the CJ-1000A to receive the certification by 2027 and enter commercial use by 2030. Beyond the CJ-1000A, China's CJ-2000 aviation engine has achieved pivotal breakthroughs, where the CJ-1000A resolved critical supply chain vulnerability. The CJ-2000 represents China's declaration of readiness for head-to-head global competition. The CJ-2000 engine is China's first large, high-bypass turbofan engine, developed entirely domestically. It is designed to power the C929, a twin-aisle aircraft capable of carrying up to 440 passengers, with a maximum range of 12,000 kilometers, roughly equivalent to the distance from Shanghai to New York. The C929 is intended to compete with the Airbus A350-900 and the Boeing 787-9 Dreamliner on long-haul routes. In February 2025, the Aviation Industry Corporation of China, AVIC, announced that the CJ-2000 has successfully completed a rigorous 3,000-hour endurance test. By generating 343 kN or 35.2 metric tons of thrust, the CJ-2000 surpasses the GEnx-1B engine of the Boeing 787 and approaches the output of the Trent XWB engine of the Airbus A350. Its industry-leading 12:1 bypass ratio outperforms both of the Western engines, delivering superior fuel efficiency alongside competitive power. However, the CJ-2000's most critical breakthrough is its turbine blade technology. For decades, China's jet engine relied on imported turbine blades, components enduring temperature hotter than volcanic lava while spinning at supersonic speed. These foreign blades arrive at a staggering 30% defect rate, causing frequent failures, grounding aircraft, and exposing China's aviation ambitions to the mercy of global suppliers. The CJ-2000 engine changes everything. Its domestically developed high-performance blades, forged from single-crystal superalloys and protected by advanced thermal barrier coatings, operate reliably at temperature as high as 1700 Celsius degree, a staggering 200 Celsius degree hotter than their predecessor. This extreme heat tolerance is revolutionary. It has slashed its defect rates from 30% to just 7.8%, while extending service life by more than 80%. According to Aviation, the CJ-2000 now offers 50% better fuel efficiency than the GE/X engine on the Boeing 787. With this level of thermal resilience, these blades maintain precision even under extreme weather conditions. And thanks to their extended lifespan, maintenance costs are reduced by millions per aircraft annually. The gap between CJ-2000 and leading global engines is now minimal, and in some areas, the CJ-2000 even surpasses them. The success of the CJ-2000 marks not only a breakthrough in engine technology, but also signals China's imminent development of the globally competitive wide-body aircraft, the C929. The C929 outperforms the Boeing 787 in key metrics: 20% lighter, triple the fatigue life, and has a 60,000-hour lifespan compared to the 44,000 hours on Boeing 787. This means the C929 has longer, narrower wings that generate less drag, giving it better flight efficiency than the Boeing 787. But what makes the C929 truly revolutionary is not just the performance. It's the fact that 90% of the components, which include basic parts such as the fastener, panels, wiring, etc., and 70% of the core system, such as the engines, avionics, landing gears, are now made in China. According to the South China Morning Post, a COMAC executive informed partners at the 2025 Paris Air Show that the C929 is expected to receive domestic certification by 2032. While the trade ban may disrupt C919 production in the short term, it has ultimately accelerated China's aviation independence. Even so, challenges remain. The CJ-1000A must achieve CAAC certification by 2027, with international approval from EASA and FAA potentially extending to 2030. By the time the CJ-1000A completes this lengthy process, its market competitiveness against next-generation Western engines would face serious challenges. Similar certification hurdles await the CJ-2000 of the C929. Yet, a pivotal shift is underway. For the first time, China isn't merely catching up, it is forging its own path in aviation. Beyond countering the US export controls, this engine advanced a more profound mission. Building an end-to-end domestic aviation ecosystem, each turbine blade, forged and test cleared, represent another step toward a self-sustaining aerospace industry, where China no longer requests permission to fly, but sets the standard for how the world takes wing.